As you know, a log is an inverse of an exponential function. So when we say inverse, we mean this: f inverse x equals y if and only if the function at y is equal to x. Here's our inverse log function. Log to the base a of x equals y if and only if a to the y equals x. That's how we defined it. What are the restrictions on that base? The base has to be bigger than 0 and not equal to 1. Okay, so just a reminder to get your head back in the game here. When I say the log of 0.001 is -3, that's because the base here, when it's not written, is 10. 10 to the -3 is 0.001. If I say log to the base 2 of 32 is 5, that's because 2 to the power of 5 is 32. Okay, we all remember how to change from log form to exponent form. Okay, remember your log laws. Oh, since logs are inverses of exponential functions, then this is true. If I take an exponential function and operate the inverse on it, I'm going to get x. If I take a log function and operate the exponential on it, I'm going to get x. I think this one is easy to see. Let's do a quick little proof for both of them. So log to the base a of a to the power of x. Our power law tells us the x can come down in front. I'm going to get x times log to the base a of a, which is asking you, to what power do you raise a in order to get a? 1. So you're just going to be left with x, which is why log to the base a of a to the x is equal to x. Check. How about this other one? When I take a and I raise it to the power of log to the base a of x, how come I also get x there? Here's how we do the proof. We say this: let's imagine a number y. We're going to call that number log to the base a of x. If y is equal to log to the base a of x, then this has to be true. A to the power of y has to equal x. Okay, so then let's start from the beginning. I've got a to the power of log to the base a of x. Then instead of writing log to the base a of x, I'm going to write y. So I've got a to the power of y. Well, what is a to the power of y? What is a to the power of y? It's just x. So log to the base a of x is the same as a to the y, but a to the y is just x. So I think we did this proof by number examples last year, and I think we did it this way. If I said 10 log to the base 10 of, let's say, 5, and I said, what's, oh, I made it easier. And I put, let's say, 100 in here, and I asked you to solve it for me. What is 10 raised to the power of log 100? And what's the answer to that? Well, we have to go about this from the inside out, as in start by answering this question: what's log of 100? To what power do I raise 10 in order to get 100? It's 2. Now, raise 10 to that power, what do you get? 100. Okay, so you're operating a function on its inverse. Whatever you put in is what you get out. Okay, log laws, remember them? When you're multiplying inside, you add outside. When you're dividing inside, you subtract outside. When you have a power, you can bring that exponent down in front. Okay, so how do we simplify these? Well, the bases are the same and you're subtracting. Law 2. Change that into a division. This becomes log to the base 2 of 80 over 5. what is 80 divided by 5? Log to the base 2, I guess it would go into there, what, 16 times? Which is just asking you, to what power do you raise 2 in order to get 16? 4. Okay, would you please do the next question? Remember, when the base isn't written, assume it's 10. Are you guys all getting 2? Okay, and this one, the bases are the same and we're adding, so we've got log to the base 3 of 6 times 1.5, which would be log to the base 3 of 9, which would be 2. Okay, natural logs. The logarithm with a base of e is called the natural log. It means you've got log to the base e of x, and because it comes up so often, we give it a name. We call this ln x. So you pronounce it just like go mow the lawn, but you write it ln x. Okay, so that's how it's pronounced. And this is what it means. If the ln of x equals y, then e to the y is x, which tells you that the ln of e to the x is x, and e to the power of ln x is x. Okay. Can you find x if the ln of x is equal to 5? Well, look back at the definition. Ln x equals y means e to the y equals x. Ln x equals 5 means e to the 5 equals x. This is an exact answer. Can you tell me to 2 decimal places what the answer is? 148.41. Okay. And remember that although that looks so nice and accurate, it's approximate. You're rounding off. Okay, let's look at solving some equations, only now we're going to be working with the base of e, which you will for most of this year. So solve the equation e to the power of 5 minus 3x equals 10. We're looking to solve for a variable in the exponent. We want to take the log of both sides. When the base is e, we're going to take the ln of both sides. Okay, so I've done the same thing to both sides of the equation. I've taken the ln. And then I'm going to use my power law and bring the exponent down. That is 5 minus 3x times the ln of e is equal to the ln of 10. Okay, what's the ln of e? Well, this is just going to equal 1. So I have 5 minus 3x is equal to ln 10. Solve that for x, subtract 5 from both sides, and I get negative 3x equals ln 10 minus 5. And finish this up, I get x equals ln 10 minus 5 over negative 3. Or I guess we could have written it this way, 5 minus ln 10 over 3. Pull out your calculators and convince yourself that those are both the same thing and that you know how to move a negative sign from a numerator to a denominator or vice versa.